sustainability? Introduction. This is a slightly different section to the other core sections we have looked at so far. The focus here is not on some abstract philosophical theory. Rather, the focus here is on a problem, a real-world problem. In fact, some of us think that this particular problem may be the problem of our species in our times, the sustainability problem. Warning: some of what we present here will shock you. What we hope is that it shocks you into beginning a journey of thinking about real solutions. So, what is this sustainability problem then? Well, check out Figure 1 below. Figure 1, the sustainability problem, 2008 data. Does this say anything to you? Does it move you? I imagine it's not exactly horrifying yet. In fact, as graphs go, it's beautiful really, don't you think? It's got everything. Bubbles. But not just any bubbles, different size and different color bubbles. It also has lines, dotted and different colors. And look at the beautiful sliding J shape that the bubbles make. Okay. We get a bit carried away whenever we present this graph. The important thing is that this is not just a pretty face, pretty graph. It tells a story too. So, what does it tell us? Well, read on. The Human Development Index, HDI. Let's start out by clearing everything off the graph which we showed you in Figure 1 above. In other words, let's deconstruct it. Figure 2, blank space, a bit like your lecturer's brain on many an occasion. And then we can build it up again from the ground. The first thing that we do is add the x-axis, the horizontal one. On this axis is a variable called the Human Development Index.
Figure 3, Step 1, add the Human Development Index. And, surprise, the Human Development Index, HDI for short, is a measure of human development. It's a number which is published by the United Nations Development Programme, the UNDP, and you can read up much more about it at the following site, http://hdr.undp.org/n/statistics/HDI, site last checked, May 29, 2018. But in a nutshell, according to the HDI, the level of development of a group of people can be evaluated by measuring three things: the health of that group of people, the level of education of that group of people, the wealth, specifically the financial wealth, of that group of people. So, what the UNDP does is chuck a bunch of measures for these three things into a calculator which miraculously comes up with a number between 0 and 1, as you can see in Figure 3. A score of 0 is undeveloped. In fact, it is probably not possible to get 0. Even an earthworm has a life expectancy and therefore some measure of health. At the other end, 1 is absolutely developed. But again, scoring a 1 is probably technically impossible. There is an important threshold in the HDI. 0.8. Any group with an HDI greater than 0.8 is considered developed. Any group with an HDI less than 0.8 is considered developing. This is indicated by the vertical line in Figure 3. Anything to the right of this line is developed while anything to the left is developing. That's the HDI. What's next?
The ecological footprint. Well, the next step in reconstructing Figure 1 is to add the y-axis, the vertical one.
Figure 4, Step 2, add the ecological footprint. This is a variable called the ecological footprint. Not quite as easy to figure out what this is all about as it was to figure out what the HDI was about, right? Although the word ecological does probably make you think environment perhaps. And indeed, this is in fact a measure of environmental sustainability. But how does it work? Well, if you look carefully, the units in which ecological footprints are measured is hectares, per capita. Now a hectare is a measure of area, specifically it is 100 x 100 m or 10,000 square meters. That's a little less than the area of 2 football fields. And basically, the ecological footprint is a measure of the area of planet Earth that is needed to support a person. That's why it's per capita or per person. If you think about yourself, it's the area of the Earth that will support your personal lifestyle. As with the HDI, you can go read up a bit more about the ecological footprint at the following site, http://www.footprintnetwork.org/n/index.php/gfn, site last checked, December 8, 2021. Now this area isn't as simple as the size of your backyard. Duh. In addition to the size of your backyard, you must think about the area that it would take to grow the vegetables that you eat, graze the animals you eat, produce any seafood that you eat, grow the trees that provide the paper that you use, and the big one, produce the energy that you use.
Add all of this up and you get your ecological footprint. So, if you eat a lot of food, use a lot of paper, drive a huge car, fly overseas 4 times a year, and leave your lights on all the time, your footprint will be high. If you eat less food, ride a bicycle to work, have never been in a plane and turn off your lights, your footprint will be lower. But how does this relate to environmental sustainability? Well, as with the HDI, there is a threshold on the y-axis too, the yellow dotted line. And it works like this: if you take the area of the entire planet and divide it by the number of people on the planet, the population, you get how much area each person should get if everyone got equal shares. And this number was about 1.8 ha. So, if your footprint is greater than 1.8 ha, you are using more than your share, i.e., you are unsustainable. Remember what Kent said, a thing is only okay if you can imagine generalizing it to all people, and if all people are using more than their fair share, we would run out of planet Earth, right? If your footprint is less than 1.8 ha, you are living sustainably.
Now that we have the axes and thresholds, we notice that the graph is logically divided into 4 quadrants, Figure 5. Figure 5, Step 3, Defining the quadrants. To really understand these quadrants, it is useful at this point to introduce a very popular definition of the concept of sustainable development attributed to a famous report known as the Brundtland Report. Sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. United Nations 1987 Report of the World Commission on Environment and Development, Our Common Future. Annex to Document A/42/427, Development and International Cooperation, Environment.
So keeping this in your mind, and starting in the bottom left corner, we have a situation where the group in question has an HDI of less than 0.8, i.e., it is developing. and an ecological footprint of less than 1.8 ha, i.e., it is sustainable. Thinking of this in terms of the Brundtland definition of sustainable development, the group is not really meeting the present needs of the people, but on the plus side, it is not compromising the ability of future generations to meet their needs. Not entirely good, and not entirely bad.
If we then move clockwise to the quadrant in the top left corner, we have the situation where the group in question has an HDI of less than 0.8, i.e., it is developing, and an ecological footprint of greater than 1.8 ha, i.e., it is unsustainable. Thinking of this in terms of the Brundtland definition of sustainable development, this group is not really meeting the present needs of the people, and it is compromising the ability of future generations to meet their needs. This is all bad. Moving right along to the top right corner then, we have the situation where the group in question has an HDI of greater than 0.8, i.e., it is developed, but it has an ecological footprint of greater than 1.8 ha, i.e., it is unsustainable. In terms of the Brundtland definition of sustainable development, the group is now meeting the present needs of the people, but on the downside, it is compromising the ability of future generations to meet their needs. As with quadrant I, this is not entirely good, and not entirely bad. Finally, we come to quadrant 4 in the bottom right. Here we have the situation where the group in question has an HDI of greater than 0.8, i.e., it is developed, and it has an ecological footprint of less than 1.8 ha, i.e., it is sustainable. In terms of the Brundtland definition of sustainable development, the group is now meeting the present needs of the people, and it is not compromising the ability of future generations to meet their needs. This is all good. This is where we want to be.
The problem.
We still don't know what the problem is though. But at least we are now in the home straight, we know what the axes on figure 1 mean. So let's put all the bubbles back and do the last explanations. Figure 6, step 3, put the bubbles back. Each bubble on the graph represents a country. You can see this because we have labeled 1 or 2. The size of the bubble is proportional to the population of the country. The bigger the bubble, the bigger the population. To be precise, from biggest to smallest, the population categories are as follows. Greater than 1 billion, there are only 2, China and India. 100 million to 1 billion. 20 million to 100 million. 10 million to 20 million. 5 million to 10 million. Less than 5 million. The color of the bubble tells you about the region in which the country is found. You can see the detail in the key at the top of figure 6. Right. Now, finally, we get to the heart of the issue, the problem. There are 2 things on figure 6 that you should be able to spot which we have not yet discussed. The shape of the graph. The red horizontal line at an ecological footprint of 2.6 ha. These 2 capture the problem, which is as follows. If you calculate the average ecological footprint for all people on Earth, the number you get is 2.6 ha. And you will immediately appreciate that this is greater than 1.8 ha. In fact, it translates into roughly 1½ Earths. In other words, we are consuming more than we have, or if you like, at a global level we are environmentally unsustainable. And if that is not enough, the shape of the graph tells us that in general, as we develop, as countries move from being developing to being developed, we become exponentially less sustainable. Oh. But surely this can't be right? If there is only 1.8 Ha per person, how can we be using 2.6 Ha? Good question. The answer is this. A long time ago, between 250 to 350 million years ago to be precise, big chunks of the planet was covered with forests. Then something happened. We're not sure exactly what, but rumor has it that a large meteorite, or meteorites, might have hit the Earth. Anyway, whatever it was, it caused these forests to die en masse. These dead forests gradually got covered with soil and water, and over the course of 250 to 350 million years, hey presto, they became fossil fuels. Coal, oil, and gas. They are the saved up energy which we are using today. Because of this, most of us don't need to have a little forest to grow trees for firewood to supply our daily energy. So, in essence, we are living on savings, and this is why our footprint can get bigger than 1.8 Ha. But this is not sustainable. At some point we will use up 250 to 350 million years of savings. And besides which, burning these fossil fuels is causing another little sustainability problem which you might have heard about: climate change. For more information on this, go and look at http://www.unep.org/climate change, http://www.newscientist.com/topic/climate-change. So what, you might say? Well, let's go a step further and begin to speculate on the realm of possible solutions that we might consider. It's in examining these that things get shocking. Very shocking indeed. Be warned, this is where things should get disturbing. But let's be brave and see what all the fuss is really about. In essence, there are two possible solutions.
Solution 1. Reduce per capita footprint.
The first obvious solution is to reduce the per capita footprint, down to 1.8 Ha to be precise. In other words, we do something, anything, to bring the red horizontal line on the graph down to the yellow horizontal line. And there are two broad ways in which we can do this. Let's start with the solution that seems to be most favored: improved technology. And we are looking at improved production technology. The basic idea here is that we're supposed to be a smart species. For crying in a bucket, we have put people onto the moon. So surely, we can figure out smart ways to produce the stuff that we consume in a smaller footprint area. Obviously, this is the most favored solution because there is nothing particularly shocking or alarming about it. There are, however, a couple of problems which we need to think about before we conclude that some smart engineer is going to solve this problem for us. Most people believe that we really are innovative enough. But let me pose this challenge to you: when was the last time we really had a revolutionary innovation in transport technology? Probably in the first 40 years of the 1900s, when we took to the skies. Since then, not a lot has really changed if you think about it. Sure, our cars have airbags these days. But they are still generally powered by internal combustion engines. And if you think hybrid cars are the answer, you might want to check out the fuel consumption of the Lexus hybrid SUV compared to other comparably sized SUVs. It's actually less efficient than many. So, what if we are not really as smart as we think? The next problem is kind of related to the first. Depending on how smart we actually turn out to be, developing the technology necessary to reduce our per capita footprint is going to take more or less time. The thing is though, we are already at 1.5 times our planet's entire capacity. The other little thing is, that the human population is growing every day. In 2008, the year the data in the figures above comes from, the world population was estimated at about 6.7 billion people. On the 27th of October 2011, it apparently reached 7 billion. By January 2022 it hit 7.9 billion. It should hit 8 billion at some stage early in 2023. What does this mean in terms of the graph? Well, it means that today the available ecological footprint is actually not 1.8 ha anymore, but 1.52 ha. The horizontal yellow line is moving down on the graph, or if you like, the clock is ticking. Time is an issue. Okay, so we might, or we might not, be smart enough to reduce our per capita footprint. And we might, or we might not, have the time to reduce our per capita footprint. But assuming that we have the brains and the time, the next thing we really need to ask is whether we really want to. This might seem like a pretty stupid question. But if you really think about it, you have to wonder. This issue is really most apparent when we consider technologies which could help us become more sustainable and which actually already exist, like solar energy for instance. We know how to capture solar energy and have done for many years now. And yet, in South Africa at least, our major forward energy supply strategy as a country is largely based on coal. The same can be said for many other parts of the world. So, we have some technology, but we don't seem to have the will to really implement it. Incidentally, when things don't make logical sense, you really do need to ask who stands to benefit from the apparently irrational behavior. It must be someone powerful. So, who does own the coal mines? Last, but definitely not least, we need to think about what will actually happen if production gets more efficient. Well, for better or worse, we live in a capitalist society where consumption is king. So inevitably when someone develops a technology that makes production of some commodity more efficient, this saving usually gets split into two, at least so the theory goes. A little bit will get passed back to the consumer, the commodity becomes a bit cheaper. In effect, this makes the owner of the new technology more competitive in the marketplace. And the bulk of the other savings will go back to shareholders, the business of business being profit for the owners and all that sort of stuff. The bottom line is that consumers and shareholders are going to have a bit more cash. And in a consumption society, what do we do when we have spare cash? We buy stuff. The point is this production efficiency stuff can only work if we actually bank the savings. It is not going to work if we just use the saving to buy a whole lot of other rubbish which will clog up our cupboards or garages. This unfortunately is not my original idea. If you are interested in reading more on this, why don't you check out Jevons paradox? So, there are problems with the preferred solution to the sustainability problem outlined above. Big problems. Given this, we must then begin to consider the alternative, and as you will see, less favorable solutions. We can reduce our per capita footprint in another way. We can consume less, eat less food, drive a smaller car, or better still ride a bicycle, fly overseas less frequently, etc. Sounds okay, right? Well, it's not okay at all in our current global political economy. Consumption is what fuels economic growth. So, if you reduce consumption dramatically, you risk throwing the economy into a recession. Why do you think the Chinese are so willing to lend Americans money? Well, on a global scale there are very few countries who have mastered the art of consumption the way the Americans have. If you don't believe me on this, just look at figure 1. Sure, the United Arab Emirates has a slightly higher per capita footprint. But there are less than 5 million people there. In America there are over 300 million. The point is, if the Americans stop consuming, Chinese economic growth is at risk. Simple. Although I'm not sure why the Chinese don't just lend the money to the 1.4 billion Chinese people so that they can consume more. The point is that reducing consumption is not something which we seem likely to take very easily. But we might want to ask ourselves how big the problem would be. Well, we can get a rough idea by looking at gross domestic product, GDP. Most of you will have heard about this, but for those of you who need a reminder, GDP is basically one measure of economic activity. It's important because 2 successive quarters of GDP shrinkage marks a recession in the minds of many. And a big part of the numbers that make up GDP is consumption. So, let's use this as a proxy for consumption. Figure 7, World GDP, nominal, over time, blue line. And the approximate effect of adequate consumption reduction, orange line. Figure 7 then shows the world GDP between 1960 and 2016. Data from https://data.org/indicators/newyork.gdp.mktp.cd, accessed, May 29, 2018. So now we can ask, what is it we want to achieve? Well, we want to reduce our average ecological footprint to about 2/3 of the present footprint, 1.8/2.6 to be precise. So, it stands to reason that we would need to reduce our consumption, as proxied by GDP, to about 2/3 the present consumption. The effect of this is shown in the red line on figure 7. This would take world GDP back to about the 2003 level. Doesn't sound so bad. But check out the size of this relative to the actual recession that happened during the global financial crisis, which started in 2008. It's huge. And remember, in South Africa, we lost 1 million jobs during the 2008 financial crisis. So, let's face it, reducing consumption is no easy solution. Of course, if you think this is alarming, now we really get crazy.
Solution 2. Increase available footprint.
The second solution suggested by the graph is to increase the available footprint, up to at least 2.6 ha to be precise. In other words, we do something, anything, to bring the yellow horizontal line on the graph up to the red horizontal line. And once again, there are 2 broad ways in which we can do this. Look, we could pretend to think about this, but 50-odd years of space exploration has not really yielded anything to give us much hope that this is possible. So, let's just move right along. There is no comfortable way to say this. The second possible way to bring the available footprint up to the current consumption is reducing the number of people on planet Earth, i.e., genocide. In other words, we carry on consuming at present, or even higher, footprint levels, but we are able to do so sustainably because we are taking the area of the Earth and dividing it up between fewer people. Okay. Now sane people would never really advocate such a solution. However, we're going to explore it in a bit more detail anyway. The reason for this is that by looking at what would actually be required, we perhaps really begin to appreciate the scale of the problem which we are facing. So, how many people would we need to wipe out in order to make our consumption sustainable? Well, the answer to this would depend on the level of consumption that we want to sustain. So if we wanted to sustain a level of consumption equivalent to the average consumption in the United Arab Emirates, the least sustainable country on Figure 1, we would need to wipe out more people than if we wanted to sustain consumption equivalent to the average Chinese consumption. But what are the actual numbers? Well, check out Figure 8. Figure 8, wipeout needed to sustain various consumption levels. What does this tell us? Well, to make the average consumption of the least sustainable group of people on planet Earth, i.e., citizens of the United Arab Emirates, sustainable, we would have to wipe out 5.5 billion people. To make the average consumption of the US sustainable, we would have to wipe out about 5.3 billion. To make the average consumption of the most sustainable major Western European country, happens to be Germany, sustainable, we would need to wipe out 3.5 billion people. For South African average consumption to be made sustainable, we would need to wipe out more than 2 billion people. And so on, and so on. Why have I put the last 5 bars on the graph? Well, those of you who know your history will know that these 5 events are the biggest genocide events which we know about, or rather that we talk about. We tend not to talk about the genocides associated with colonization for some reason. Mao Zedong's Cultural Revolution, 70 to 100 million. Nazi Germany, 6+ million. Stalin's Russia, 6+ million. Cambodia, 2 million. Rwanda, 1 million. The important thing here is that besides Mao's efforts, you can't even see any of these on the scale of this graph. This, ladies and gentlemen, is crazy stuff. Even with the declining population in much of Western Europe and efforts such as China's one-child policy, the human population continues to rise alarmingly. And remember, we are already consuming the productive capacity of 1.5 planets. This is the problem. Next, please go to assignment 7 about sustainability.